welcome to Written Zero YouTube channel. So today the video is going to be about TLE. So this is a problem that a lot of beginners who are starting with competitive programming face. So what is TLE? So TLE stands for time limit exceeded. That is, sometimes you submit a solution in any of the online judge, and you see your solution is not getting accepted, though it is passing all the test cases, and the reason that it is going to give is going to be TLE. So what is TLE and when do you get TLE? So as I told, TLE stands for time limit exceeded, and you're going to get this when this solution that you're going to submit is not able to produce the required output in the given time. So it is taking more time than the time that is allotted in the online judge. So how can you solve the problem of TLE, or how can you make sure that your solution gets submitted? So as I told, you have to find a way so that your solution is executed in a smaller duration. So how do you approach when you get the problem of TLE? So if you have to make your code run in a shorter duration, so it is not dependent on reasons like the number of lines of code, but it is dependent on the method or the algorithm that you have used to reach to the solution. So if you have to make your code run in a shorter time, so you have to use the algorithm that is more optimal and runs in a shorter duration. So how do you say which algorithm is more optimal? So for this, you have to know one more terminology or concept called time complexity. Okay, so what is time complexity? So time complexity gives you the amount of time that your code is going to take to run with respect to the number of inputs. Fine. So it is not going to give you the exact time that your code is going to take to run, but it is going to give the amount of time that it will take with reference to the number of inputs that your code is going to take. Now let us have a glance at some of the most common time complexities and understand how you can reach to the most optimal algorithm for your solution. Okay, so the first kind is O of n. So this kind of representation is known as big O notation. So what does O of n means is, let's say, give an example. Let's say you have an array of size n as an input and you're looping through each and every element of the array. So in this kind of approach or this kind of solution can be termed as O of n, where you are having a single for loop and you're traversing through each and every element of the array. So the next kind of example is O of n square, where you're having for loop nested, like two nested for loops. So to give an example, let's say you're given an array as an input, and for each and every element you have to loop through each and every element of an array. So let's say give an example where you have to perform certain kind of operation for every pair in an array. So for this you have to go through you have to opt for the solution that is going to be of time complexity O of n square. So you can see here we are having two for loops that are nested under each other. So whatever the statements you're going to, whatever the statements we are having, so we are having, let's say, an array of size n, and for each element we are looping through each and every element of the array. So these statements are going to be executed to the order of n square. So now let's move to the next example, that is O of 2 power n. So this kind of time complexity can be observed in recursion, where in this example you can see that inside the function you're having two function calls. So if you plot the tree diagram, you can see that for every n, for integer n as an input, you can see that there are 2 power n function calls. So moving to the next one, O of log n. If you see in this while loop, let's take an example. Let's say x is 16. So in the first iteration, x is going to be 16. In the second iteration, it is going to become 8. And next iteration, it is going to become 4, then 2. So you can get an idea how the number of times that the loop is going to get executed it is log with base 2 times of the input. So you can say that the below mentioned code is having time complexity of O of log n. So this is a input table and the time complexity required. So the first thing that you have to keep in mind is speaking about a language like C++ or Java, it can perform around 10 power 7 to 10 power 8 operations in a second. Okay, so it can execute around 10 power 7 to 10 power 8 operations. So when you are given 10 power 8, around 10 power 8 operations, you can see here. So then you should you can have the time complexity of O of n, right? So if you're having a if you're having that the input constraint is around 10 power 4 or 10 power 3, so then you can have the time complexity up to O of n square, right? Because if you see, if you are having input constraint up to 10 power 3, so around in O of n square kind of solution, there are around n squared times the solution there are n square operations that will be performed. So if you are having input size of around 10 power 3 or 10 power 4, so you'll finally have 10 power 8 operations in 1 second. Okay, so in the first example, that is the time complexity of O of n factorial. So if you see around between 11 and 12, between the 11 factorial and 12 factorial is going like 10 power 8 is going to be between 11 factorial and 12 factorial. So if you're having input size of around 10, then you can go up to a time complexity of O of n factorial. So depending on the input, you can choose the required time complexity. So now let us take an example and try to understand from the example. So you might have come across this problem, that is maximum subarray sum. So what we have to find is we have to find a subarray, means a continuous part of an array. Like so let's say the continuous part can be from second element to fourth element or second element to fifth element. So you have to find a subarray that is having maximum sum. So let us see how let us go to an online judge and see let us go from the most basic approach and try optimizing with a better approach. So here we are having the same problem in Geeks for Geeks. So let's try to solve this problem with starting with the basic approach. So here we're given an array n, and we have to find the subarray with maximum sum. So how is the brute force or the most basic approach that we are going to take? That is, we are going to have the first for loop to choose the leftmost element, and the second for loop, that is this one. This is we are going to use this for loop to choose the rightmost element, and the third for loop to loop over elements between the leftmost and the rightmost element. So here we are going to loop over every pair of element, and then we are going to find the sum of all the elements that is between these two elements. So here you can see that we are having three nested for loops, and the complexity is going to be O of n cube. Okay, so let's try to execute the sample test cases. So here the sample test cases is working completely fine, and now let's try to submit the solution. So as you can see, we got a runtime error stating that time limit got exceeded. So how can we make this solution better? So as we know that now this solution is having time complexity of O of n cube. Now we have to reduce it to the time complexity. Let's try reducing it to O of n square. So now let's try making the solution little better. Okay, earlier we had O of n cube, that is 3 nested for loops. Now we have tried reducing it to only 2 for loops. So how this method or this algorithm works is, first it is going to take first element, let's say 1, and then it is going to find all possible subarrays that are going to start with 1, like it can be 1 1 2 and 1 2 3. So similarly, it's going to find all subarrays that is going to start with 1. So next it is going to take 2, and then find all the subarrays that is going to start with 2 and find the sum of that particular subarray. So 2 and 2 3 2 3 and minus 2, so yeah, and so on. Okay, so here you can see that we're only having two for loops, two nested for loops, and yeah, two nested for loops, and the complexity of this solution is going to be O of n square. So let's try compiling and running. So the sample test cases are running fine. So let's try submitting this. So as you can see, even this solution is it is showing as time limit being exceeded. So now we're going to we'll try to make the solution little better. Like first we started with O of n cube, and then we try to make it more optimal by reducing it to O of n square. Now the more better, like the better approach is going to be O of n. So how could one try to solve in O of n? So yeah, so that the particular solution that is going to solve this problem in O of n is only named as Cadence algorithm. And yeah, so how we can do is, so in this approach you can see that the solution is only having one for loop, and the complexity is going to be O of n. Okay, so here I've tried to track down what happens in each iteration. So we have this particular array as input, and for each iteration what is going to be the value of sum and answer. So maybe observing or tracking down how the values of sum and answer variable is going to change is better way for you to understand this algorithm. Yeah, so let's try compiling and running. Yeah, so our sample test cases are working fine, and so you can see that this problem got accepted, right? So you can see that the problem got accepted because the time complexity of this particular approach was O of n. This was the best possible approach that we could have brought this solution to, and yeah, so similarly, like this got accepted. All right, so this is the efficiency comparison table of the number of input, like the input size and the time that it is going to take. So if you remember that I told like general compilers of C++ and Java can perform around 10 power 7 to 10 power 8 operations in a second. So if you see that the first approach was O of n cube, and it is going to take more than 10 seconds because it has to perform around if you're going to provide 10 power 8 as the input size, it has to perform around 10 power 24 operations. Okay, so that is going to take a lot of time. So yeah, and cadence algorithm is linear time, and it is it is of O of n time complexity, and it is almost going to take near to 0 seconds for inputs up to size 10 power 8. Yeah, so that's it. Thank you. And for more content related to competitive programming, please subscribe Written Zero YouTube channel.